Hello, my name is Brian Newton, and today I will be presenting on the Nebraska Sandhills, more specifically, using geographic information systems and the Cropscape database to understand the effects of precipitation on surface water and vegetation in the Nebraska Sandhills. As far as we could see, the miles of copper-red grass were drenched in sunlight, and the whole prairie was like the bush that burned with fire and was not consumed. This quote by Willa Cather, I think, best describes the experience of being in the Sandhills and seeing how they change with the seasons. This beauty and grandeur is one of the many reasons that I chose to do my research in the Sandhills, and seeing someone express this in such an artistic way really adds another dimension to the Sandhills and their beauty. Today I will be talking about what the Sandhills are, why we studied them, and the study area. I'll then go over Geographic Information Systems, otherwise known as GIS, why we use GIS in the Sandhills, and some of the tools that we used within GIS in this study area. I will go over the application, meaning what we studied and why we studied it, the hypothesis, which was that during a drought in 2012, the vegetation would decrease due to the lack of water and then increase in 2013 as a recovery period. And I will discuss results, and then we'll have a bit of discussion after, and then I will field questions lastly. So what are the Nebraska Sandhills? The Nebraska Sandhills are a geographic region in western Nebraska marked by the presence of large sand dunes, colloquially referred to as sandhills. This area is very important to hay farmers and cattle ranchers due to the large quantity of grass and other grassy plants that can be grown in this region. To be more specific, the sandhills are about 5 million hectares of sand dunes, stretching 426.5 kilometers across Nebraska and into South Dakota. They are one of the largest grass-stabilized sand dune regions in the world. They are geographically young at only 8,000 years old, and home to ranchers and hay farmers who claimed this land after the Kincaid Act was passed in 1904. Since in this region it takes so much land to turn a profit, most of the land has been consolidated to one owner. Sometimes he or she may own up to 6,000 acres of land just to turn a profit. So why did we study the Sandhills? The Sandhills of Nebraska are one of the primary recharge locations for the High Plains, otherwise known as Ogallala Aquifer, one of the largest aquifers in the world. The Sandhills are also home to native flora and fauna that are rare and endangered in Nebraska. The unique combination of these flora and fauna make the Nebraska Sandhills one of the most unique ecosystems in the world, worthy of conservation. The Sandhills are also a unique and short-lived geological feature in Nebraska. So as the aquifer is drained to support row crop agriculture, we need to pay attention to how the aquifer is recharged and precipitation patterns that will affect the long-term withdrawal from the aquifer. Extreme hydrological events, such as drought and floods, which we've seen in the recent years, will affect the biological diversity of this system. So about the unique geology of the Sandhills. In the late Pleistocene epoch, it is theorized that the rivers and streams that flowed through this region were blocked by dune sand, which formed the Sandhills. This raised the water table 25 meters over 7,000 square kilometers and created about 1,000 lakes. These hills are a very short-lived geological feature. As I mentioned before, they're only about 8,000 years old, and it's projected that they'll only remain for 2,000 to 4,000 years after this. So they're very, very unique as far as geology goes. The unique hydrology of the Sandhills. So I present here a graph that shows the infiltration rate above the map of sand in the yellow, which is higher than any other material. And so this really illustrates how porous this sand is and how the infiltration rates can really affect the aquifer. This allows the sandhills to be the one place in the Ogallala Aquifer that seems to be growing and not shrinking. As you can see in the map, it has about a 1,000 foot saturated thickness, so that's a lot of water there. In this region, the water table is so high that we can measure the groundwater in this area using satellite imagery. In this study, we use this fact to show the change in groundwater over time and how this can affect ranching and the availability of hay in this area. So about the unique ecology of the sandhills. So the blowout penstemon grows in blowouts. What are blowouts? Blowouts are formed as strong winds deposit sands from the windward side of a dune to the leeward side and create a sparsely vegetated crater-like depression. As Alex said in his presentation, these look very similar to sand traps on a golf course. So these indicate a loss of productivity and are thus stigmatized by farmers in the sandhills. So when the sand dunes are removed, the penstemon doesn't really have anywhere to grow, and so it has become endangered in the past couple of years because the farmers and the ranchers there have started to remove these blowouts, and they're actually very important to the ecosystem out there. So the Topeka shiner is a small minnow that lives in pools and oxbow lakes out in the sandhills. And as we see the shrinkage of these pools and lakes, as I'll get to later, we also see the endangerment of the Topeka shiner. So why did we choose Grant County? Grant County is ideal for this study, as data for this county are very representative of the overall hydrological conditions of the sandhills and can be interpreted as such. We also found that there is not too much data in this county as in other counties, such as Cherry County, and not too little data in this county, such as in Dakota County. So I actually did some examinations of Cherry County in the early stages of this study and found that there was way too much data. We were looking at over 1 million pixels, which was way too much, and so we wanted a smaller area, and so the next logical place was Grant County. Not only do we have very good data from this county, but it also sits in the middle of the aquifer and can be interpreted as such, and contains some of the unique species of flora and fauna that I was talking about earlier. So a quick little introduction to GIS. What is Geographic Information Systems? GIS is a framework for gathering, managing, and organizing data. When we talk about geographic information systems, it's really an umbrella term for a lot of software. ArcGIS is a specific type of software, and in this study we used ArcMap, which is a software produced by ArcGIS. So we're talking about very specific software here. So GIS is rooted in the science of geography and integrates many types of data. What we used here was KML and shapefiles that are easily loaded into GIS, as they always have geographic data and can be easily imported into the software. So GIS analyzes spatial location and organizes layers of information into visualizations using maps and 3D scenes. So we actually used it primarily to map out these changes. So where was the change happening and how big was the change in those areas. So some tools within GIS. In ArcGIS, there are over 200 tools just for geoprocessing. For this research, we are only interested in these geoprocessing tools, which are more along the lines of spatial data. Basically, what geoprocessing is we are given a large raster data set, and we want to break that raster set down and visualize it. So that's pretty much what geoprocessing is. And so geoprocessing is just one toolbox out of about 20 toolboxes in ArcGIS, specifically ArcMap. And there are over 200 tools within geoprocessing. And so if we look at all of ArcMap, there's probably about 4,000 tools in all of ArcMap. That's just how advanced this software is. For this study, we are only interested in the Spatial Analyst toolset within the geoprocessing toolbox. The Spatial Analyst toolset allows the user to combine information from many independent sources and derive new sets of information by applying a sophisticated set of spatial operators. Basically, what it allows us to do is it allows us to look at what is happening at the ground level with a given raster data set. All of this is in a visual format, which allows the user to track every step of the process. So I was able to, with GIS, track what I was doing and how it was happening in these maps, which I think is very, very cool in and of itself. So the project, what did we study? In this research, we examined the interaction between rainfall as a climatological variable and hayable wetlands. Rainfall as a climatological variable is usually totaled for the course of the year. Here we notice the drastic drop in the rainfall in the year 2012 compared to other years. As you can see in this graph, usually we're looking at the average of 42.15 inches per year, and in 2012 we see a drastic drop in this average. We examined the change in the wetlands and the pasture classifications, as this is a very good indicator to show the change in hayable land. And we really also examined the open water pixel that is indirectly related to the hayable land. So what is the Cropscape portal? Most of the information that I used in this specific study was pulled directly from the Cropscape portal. So it contains a classification for all of the geographic points in the U.S. These come directly from Landsat 5 and 8 imagery, and all of this can be imported directly to your computer in a shape file. So it allows us to go straight into GIS and examine what is happening here at the county level. There are well over 200 classifications for all of these points in the U.S. So we really focused on 5 of these classifications: the herbaceous wetland, woody wetland, pasture, other hay, and open water classifications were specifically of interest to us. Other hay is catch-all and sometimes goes awry. We were interested in this classification at the outset, but as we continued on, we found that this classification gets kind of moved around by the USDA, so we kind of threw that one out because it can kind of go awry and is very unstable. So we're mainly looking at herbaceous wetland, woody wetland, pasture, and open water. So the hypothesis. We hypothesized that from 2011 to 2012, the open water pixels will decrease due to the precipitous drop in the rainfall variable. Then from 2012 to 2013, the open water pixels should return to some form of terrestrial pixel because of the return to normal precipitation. The herbaceous wetland, woody wetland, and pasture variables should change back to open water. Moreover, since the rainfall pattern returned to a climatological normal, the terrestrial changes should remain the same for the following years through the present year. We also examined 2011 to 2019 to lend some context to this pattern of precipitation and open water variables. So just a little bit of details about the hypothesis. So we are looking at, in this study, climatological variables. Climatological variables are on a large span of time. We are looking, for this study, we are looking specifically over about the span of 30 years. But a more powerful analysis would be over the span of, say, 50 years or 100 years, if we could get that data. So that's climatological variables. Meteorological variables are over the span of an hour, a day, or a week. So climatology in relation to the Sandhills. So what's the climatological normal in the Sandhills? The climatological normal in the Sandhills is semi-arid. So as I was talking about before, we're looking at a 30-year average of 42.15 inches a year and an average of 22.03 inches per growing season. So we're not it's not a lot of rain. And so we're trying to deal with this, and in 2012, as you can see on this graph, is specifically a large drop in this average. Since climatology is very cyclic, large variations like this huge drop in 2012 are rare. So we really wanted to investigate this and see what was happening and how some of the vegetation responded to this drastic change. So the methods. The combine tool. This is a type of GIS transformation within the Spatial Analyst toolbox in ArcMap. It combines multiple raster datasets and outputs a unique set of values for each unique set of input values. So basically, we are giving GIS two unique inputs, and it's giving us a unique output. This allows us to do very effective, very detailed change analysis over years or over months or however we want to do it. This is very useful for this application as it helps us visualize change in any sort of data. We also use the sort by attribute tool. The sort by attribute tool allows us to see those pixels that were related to water and terrestrial pixels and nothing else. So we wanted to take the output of the combine tool and see specifically what was happening to these open water pixels and how they were changing from year to year, and how these terrestrial pixels, such as herbaceous wetland, woody wetland, and pasture, were changing with the open water variable. The sort by attribute tool takes the attribute attached to a pixel and only shows us those pixels, and it uses an SQL input statement, which I kind of showed you over here. In this case, I gave the program the statement where 2011 equals 121, which is the code for open water, and 2012 equals, I believe the code is 276 for pasture. So we really wanted to look at what is changing and how is this open water going to other terrestrial pixels. A feature of ArcMap is that while it does sort this visually into nice, neat categories, it also sorts it into a spreadsheet for you to analyze. So we were able to pull this up in Excel and really see graphically what was happening. So what happened? In the 2012 drought, open water pixels shifted to various terrestrial pixels, pasture as well as herbaceous and woody wetland. This is what we expected. This was our hypothesis. We thought that it was going to decrease. We thought it was going to be a dramatic drop, and it was a dramatic drop. It was, as I'll get to in a second with the maps, you can really see around the lakes and around some of the lowlands, you can really see the pronounced ring of drying during the 2012 drought. We expected to shift back to open water the following year in 2013 when precipitation levels returned to normal. Instead, what we saw was a continued shift from open water to terrestrial pixels, particularly to herbaceous wetlands. So again, what we saw from 2011 to 2012 and then 2012 to 13 was a continued drying pattern. And so we saw some of these lowlands and some of these lakes continue to get drier. To more closely examine the change in the landscape, we selected a section in Grant County and mapped how these shifts occurred in and around the wetlands and ponds. So I really zoomed in on some of the maps, and they're the exact same spot. And this really allowed us to see, okay, where is the change happening? Where is change not happening in each of these years? We also examined change in all of these variables from the year 2011 to the present day to give some context to what is actually happening here. So what happened? So these two maps were generated by me for the 2018 GIS-LIS conference. And what I specifically wanted to look at was the change in open water pixels from 2011 to 2012 and 2012 to 2013. So in the first map, what we can see is the change from open water to some of these terrestrial pixels. We see it occurring in a pretty well-defined ring around Pratt Lake, and we can see it occurring down south here in some of the lowlands. So this indicates that these areas are drying, and basically that there was a drought. And so that's exactly what we expected. But in this 2012 to 2013, we did not expect that. We did not expect to see, again, some of these lakes that are drying and some of these lowlands that are surprisingly drying. So you will notice that I overlaid a base map here, and it's a topographic map. So you can see with some of these hills here, nothing's happening on those. We're just interested in the lowlands and some of the lakes out here. So to further examine this, I really wanted to look at some of the counts and how the counts of pixels were changing. So we can see that the change in open water to herbaceous wetland over the time from 2011 to 2019 has really increased. So it could be taken from this graph that we may be drying. I would not say that with confidence, as some of the R-squared values here were rather low, so we can't really pull anything from this graph. All I would say is that we need more studies examining what is going on here, because there's obviously something happening, but we don't have enough confidence in this data to really say definitively that something is happening. We expected to shift back to open water the following year, 2013, when precipitation levels returned to normal. Instead, we saw a continued shift from open water to terrestrial pixels, particularly to herbaceous wetlands. It is possible that the effects of the dry year 2012 continued to play out in the system in 2013, with continued shift from open water to terrestrial pixels. It is also possible that ranchers during the dry year hayed the newly accessible wetlands and facilitated a shift to herbaceous wetlands the following year. Understanding the wet meadow habitats and their response to precipitation in land management is very important in predicting potential changes for waterfowl and other wildlife, as well as changes in forage resources for ranchers. Really, there's a lot that could have gone on between 2012 and 2013 that could have facilitated this continued shift from these open water to terrestrial pixels. So I would again encourage people to really study this and to see what was happening out there. I haven't been out there, so I don't really know the rancher side of it. So I would really be interested in to hear from these ranchers and see what happened. With the realization of climate change, the Sandhills will most likely be affected due to changing precipitation. So we can kind of already see that because climate change will most likely have an effect on precipitation, that this area specifically will be affected more than, say, Omaha or anywhere else in Nebraska. A clear understanding of this area will allow for more effective ranching and hay farming practices. Really what the end goal of my study is that I wanted to help ranchers and farmers out here to really know, to help them know their land and know what is happening with precipitation, how their land responds to precipitation, and I hope that this has really been helpful to them. I would recommend further study of the Nebraska Sandhills, as they are a unique environmental system that is worthy of further study. This has been a lot of fun. It's been a lot of fun using GIS to really get into the nitty-gritty of the Sandhills and look at what's happening out there or what's not happening out there and see some of these changes. It's been a lot of fun, and I would highly recommend further study out here, because it will help us to know what's happening with the land and to help the farmers and the ranchers out there. Thank you for listening to my presentation. I will now field questions and leave you with my bibliography.